Hello all, welcome back. In this lecture, we will discuss about pass transistor logic. What is pass transistor? It is very simple, cost effective, and more. It's very less complicated and more advantageous using pass transistor logic wherever it is suitable. So, pass transistor logic is implemented using the pass transistors. Now, pass transistor means the role of the transistor is to pass or stop a signal which is given to it. If, for example, V reference is given to the transistor A, this is transistor A. This is given to a transistor A. If the gate voltage or the variable is assigned to the gate. So, if value of A is equal to logic 1, that means 5 volts, then this transistor, NMOS transistor, closes, turns on. When it turns on, there will be a path between drain to source. So this voltage VDD can pass to the output V0. In this example also, the voltage which is given as V reference should be able to pass through A and reach the output only when A is equal to 1. So to realize this function f is equal to a plus b bar c, what you need to do is you have to take three transistors. Each transistor you have to assign each variable a, b bar and c. If the voltage which needs to pass through this path is the condition is both b bar and c must be 1 and 1. That means whenever both the transistors are closed, then only the voltage VDD can pass to the output. Now this can be implemented. This B bar C, you can see, is representing the AND gate. This plus is representing the OR gate. So all logic functions that are required to be implemented can be done using the pass transistor logic with very few number of transistors. As there are very few number of transistors, you can estimate how less complex will be your circuit and how cost effective it will be. Because if you are implementing the same function using logic gate, there are certainly there are many number of transistors required to implement the logic in terms of logic gates. So logic gate implementation sometimes becomes expensive. So it can be done only when it is very necessary. The only problem with the pass transistor logic, as we have discussed, is the pass transistor logic cannot give you NMOS pass transistor logic can't give you good high. It can give you good low but not good high. So see here, the same logic a plus b bar c can be implemented like the circuit which you have seen. Now the same can even be expanded, like you can take out a, b bar, you take b and b bar, apply 0 permanently to b and b bar apply with c. Now what happens whenever b bar is true and c is there, the product of these two comes as output. So if you are expanding around a, you have to take a and a bar, multiply a with 1 and multiply a with b bar, a bar with b bar c. Now this expansion around b, if you do, again further expansion around b, if you do, this b can be expanded as b into 0 into c. Once it is c, once it is 0. So apply a 0 here, c here with b and b bar, and then a and a bar, apply both the terms, getting the same function. With 4 number of transistors, with only 4 transistors, you can realize the given logic function. So the logic function, the same pass transistor logic, this is another example. Universal logic, that is universal gates, XR and XNOR gates. The XR gate function can be realized using the pass transistor logic as shown in the diagram. Just now we have seen how we can expand. Apply that same expansion technique here. It is a bar, b bar, 0 0 0 1 1 0 1 1, like that. You have all the 4 combinations. Which combination of output we need? we need A bar B plus A B bar. So apply 1 to those two inputs only, rest of the inputs you make it 0. Now what will you get? You will get B bar A plus B A bar, which is the output. It's very simple and easy. This is standard method. This is simplified version of the pass transistor logic. Using these pass transistors, we can have the advantages like it is ratioless. That means a large function can be implemented with less number of transistors, and the power consumption you can easily understand by seeing the simple circuits. It is very less power consuming, and it occupies very less space because tiny transistors, only 4 transistors are required to implement a little function like a plus b bar c. Whereas if you are implementing the same with AND gates, OR gates, and all other things, you need to have large number of transistors. Those are the advantages of having pass transistor logic. Of course, there are some disadvantages. The disadvantages are more delay, and the major problem of this pass transistors is high static currents. The static currents, because if the transistors are continuously kept on, it will continuously give away large current to the ground. So that should not happen, which incurs lot of static power dissipation, and voltage levels are reduced. As we have seen, the output of the pass transistor logic will be VDD minus VT. So an amount of VT power, VT voltage will be reduced in logic 1 state. So, and one more issue is it requires complementary signals like what we have seen. We need A bar, B bar, like that. Making the signal into its complementary form, converting, is also incurs some number of transistors are required. So those are the problems with pass transistor logics. And coming to the pass transistor logic families, these pass transistor logic families are the regular NMOS pass transistor logic is there anyhow, which can be called as complementary pass transistor logic, which in its short form it is CPL, complementary pass transistor logic. And next is dual pass transistor logic, DPL. CPL, DPL, and SRPL are the 3 different pass transistor logic families. SRPL is swing restored pass transistor logic. Swing restored pass transistor logic. So CPL is complementary pass transistor logic, DPL is dual pass transistor logic, and SRPL is swing restored pass transistor logic. So the first one, which is complementary pass transistor logic, consists of 2 NMOS pass transistor logic networks, one for each rail. Like rail means one for power supply and one for that is one for VDD and one for ground, and it requires 2 small pull-ups, that is PMOS transistors, to restore the swing, 2 output inverters to have the complement of the result. So these are the requirements and different logic families of uh, pass transistor logic. I hope you understand. Thank you.